In this video, we're going to factor the difference of two squares. So we're going to be given a polynomial. It'll be some value squared minus another value squared. And this will be equal to, if we find what that first value squared is and we call it a, and that second value squared and call it b, it will be a plus b times a minus b. And I'm going to show you how we can use this property to help us simplify the difference of two squares. All right, so in this case here, 4x squared. Well, what value squared equals 4x? Well, 2 times 2 is 4, and x times x is x squared. So 2x squared would give us the value of 4x squared. So that means our value of a is equal to 2x minus 16. Well, what squared equals 16? Well, 4 squared. That means our value here for b would be equal to 4. So when I factor it, I just use these values for a and b that I found. That means that I have 2x for a plus 4 for b, 2x plus 4 times 2x minus 4. And that is how you factor it. Okay, if we redistributed, remultiplied, we would get back to our original answer of 4x squared minus 16. Okay, so let's try the next one. Okay, we have 4y squared minus 9. Well, to figure out what a is, I have to figure out what squared equals 4y squared. Well, I know a is equal to 2 times 2 is 4, and y times y is y squared. So I know my a value is 2y. Because if I do 2y squared, it would give me 4y squared. I know my b value is 3 because 3 times 3 is 9. Now I'm just going to plug it into this formula here, and I am left with 2y plus 3 times 2y minus 3. And that is my polynomial factored. So in this case, because it's a difference of two squares, you always have to have subtraction for the difference part, and both of the terms have to be squares. They have to be perfect squares, or else this won't work for factoring. All right, let's try a couple more. Okay, if we look at this one, you can see right away 50 is not a perfect square, but I know that if I have a 2 and a 50, I can factor out 2 because I can divide both 2 and 50 by 2. So if I factor out a 2 times 2x squared divided by 2 leaves me with just x squared minus 50 divided by 2 is 25. Now I have that perfect square. So both of these are perfect squares. When I write my answer, I have to write that 2 on the outside. So I'm going to start by figuring out what a and b are. Okay, so for a, well, what square gives me x squared? Well, just x. And then for b, what squared is 25? I know that's 5. So when I write my answer, I have to have 2 on the outside times our a value, which is x, plus the b value, which is 5, times x minus 5. So for the answer, it will always be the exact same things, but they're going to be conjugates. One has plus, one has minus in the middle. So just addition and subtraction is the only different part. All right, on this one, okay, we have 27 and we have 3. I know that I can divide both of them by 3, so I'm going to factor out a 3. But on this one, I always also have an a cubed, and it has to be a perfect square. but there's an a here. So because they both contain at least one a, I can also factor an a out. Times 27 divided by 3 gives me 9, and a cubed divided by a is a squared, minus 3a divided by 3a is 1. So I'm left with that 1 there. Don't forget, you can't just leave it blank. It has to be a 1 because 3a divided by 3a is 1, not 0. All right, so now when I write my final answer, I have to have that 3a outside, but I'm going to figure out what the a and b values are. So here for a, all right, 3 times 3 is 9, so I know I have a 3, and a times a is a squared. So a is equal to 3a, and our b value, well, is just 1, because 1 squared gives me 1. So when I rewrite this, I have the 3a outside, and don't let it confuse you that I have an a here for both of these. A is my variable in the problem, but this a and b variables out here, that's just so that I can plug them into this formula that I'm given. That's all that those mean. It's just a tool to help me figure out which numbers to plug in. Okay, so I have to do 3a plus 1 inside, and then multiplied by 3a minus 1. That is our answer. All right, so I'm going to have you try 4 very similar problems. Go ahead and complete them. Come back when you're ready for the answers. All right, so the first one, I know my a value is x, my b value is 2. So we have x plus 2 times x minus 2. Next, my a value is 5y, b value is 3. So we have 5y plus 3 times 5y minus 3. Then, okay, on number 3, well, I can factor out 20, and I'm left with m squared minus 1. Then I know that a is equal to m and b is equal to 1. So we have 20 times m plus 1 times m minus 1. Last one. All right, we can divide both 16 and 32 by 2. And I can also factor out an r. And I'm left with 18r cubed divided by 2r, leaves me with 9r squared minus 32r divided by 2r is 16. All right, now I need to figure out what a and b are. My a value is 3r, my b value is 4. So the answer is 2r times 3r plus 4 times 3r minus 4. All right, hopefully you were able to use the formula that I gave you to factor all of the differences of two squares.